So now we're going to talk a little bit about fabric extenders, or what we traditionally call FEXs within the data center. So the FEXs are a unique kind of switch, and we can't even really call them a switch because they're more kind of similar to a line card within a chassis. They're not going to have a whole lot of logic built within them. We're going to see that they rely a lot on their parent switches, be that a 5K or even a 7K. But the FEX have given us some significant capabilities within the data center that we didn't historically really have. So let's hop over and start to take a look at these fabric extenders. So what I like to say and how I like to describe them is Cisco, they kind of saw a need for a way to dramatically increase port density within the data center while also reducing cost and points of management. Traditionally, in the top of each rack within a data center, we had to usually place a switch. If costs were too much, we typically might skip a rack and throw a switch in the top of every other rack and then cross cable servers within one rack outside to another rack's switch. And this always didn't scale real well, and typically every time you put in a new switch, that was another point of management that you had to manage within the data center network itself. So Cisco designed these fabric extenders, and we'll see these typically as what we refer to as the Nexus 2000 series devices. So they essentially operate like remote I/O cards within a chassis, but the chassis in this case is going to be a virtual system, so it's not going to be a real chassis that we slide them into, because these fabric extenders are actually, they look and feel like switches. They're going to be a 1U device with a bunch of front panel interfaces, and off to the right hand side of that front panel interface, we're also going to see a couple of what we call fabric ports, or these are the ports that are going to go back to this parent switch. So the parent switch is either going to be a 5K, a 5500 series Nexus, or a 7K Nexus. So these are actually the brains. So if we're envisioning a virtual chassis, these are kind of like the supervisor modules of this guy. Now, all configuration is going to be managed by the parent switch. Cool, right? So imagine if we have a rack, or actually a row full of racks. Let's say we have 10 different racks. And let's say each one of those has a FEX in the top of it, and all those FEXs are connected back to Nexus 5548. The only point of management we have for all of those switches is the Nexus 5548 itself. We're going to perform all of the configuration for all of the ports on that Nexus 5K device. So very cool. I mean, from an administrative perspective, we're already reducing the total overhead that we have in terms of what devices we have to support. Now, we're also going to see that it provides a simplification of cabling. And this is big, right? Because we've all been there where we're tracing those cables up those racks, and we got one guy over there near the server or the source of the cable. He's kind of yanking on it. The other guy's like, no, I don't see it. And he's yanking on it some more. And finally you see one of those, pull tight, and you're like, oh, I got it. That's in, port 5. And that sucks. I mean, let's be honest about it. That sucks. So what we can do with these FEXs, because they're so darn cheap, is we can stick one in the top of every rack. So rather than having to do cross-rack cabling, we can just cable those servers straight up to the FEX in the top of the rack. That's why we often hear the FEX referred to as a TOR, or a top-of-rack switch. Now, in terms of FEX support, what are we going to have within the CCIE Data Center Lab exam? This is important if you're actually going out to take the CCIE Data Center Lab, because they actually call out a specific fabric extender, the 2232 PP. And at the time of the lab inception, this was the only fabric extender that actually supported passing FCOE traffic across it. Meaning, hey, if you're going into the lab, that may signify, ooh, that may be something I need to practice on, is how to pass FCOE down to a fabric extender. Since the lab has come out, though, there are many, many more fabric extenders out there that do support passing FCOE traffic across. Actually, I think I have a web page brought up here that we can take a look at to kind of see what some of these FEXs are, and let's erase that. So we have some 1 gig fabric extender models, and those are kind of some of the older ones at this point, but they're just going to provide some native copper connectivity. So we have the 2224, the 2248, and the 2248 TP. What we're going to see, there used to be a model out there called the 2148 and the 2124. These were kind of the Gen 1 fabric extenders. These are more the Gen 2 fabric extenders. But we can see they've got 24 front panel ports. The 2248, again, you guys should kind of be cluing in on this. The 2248 has 48 gig ports on the front of it. All right. Now we're going to see they have a certain number of fabric ports that are going to go back to the parent. This is going to cause a certain oversubscription ratio. We'll go over some of this here in just a little bit. But again, I just want to kind of show you guys all the different models of fabric extenders that are actually out there. The ones we're going to be particularly concerned with are over here on the 10 gig SFP Plus models. So over here we can see that dude that I was talking about, that 2232 PP model. This guy is actually going to give us 32 front panel ports. These are going to be either 1 or 10 gig Ethernet ports. We're going to have SFP modules to go in each of these ports, whether it be a 1 gig copper or a 10 gig fiber port. We're going to have SFP for connectivity off this guy. They're going to provide us with 8 uplink ports for him. Again, that's kind of to manage the oversubscription ratio. If you think about it, 32 10 gig ports could give us 320 gigabits per second of front panel throughput. So we kind of need to scale that back. So what they did is they gave us 8 10 gig ports as uplinks to the parent. So that's about a 320 to 80 oversubscription ratio. And if you dumb that down, that's about 4 to 1. Okay. Same with the 2124 or the 2224. That was 24 gig ports, so about 24 gig of front panel throughput, and they gave us 2 10 gig uplinks, so about 24 to 20, or about 1.2 to 1 oversubscription ratio. So again, these guys aren't too badly oversubscribed because the chances that you'll ever have all 10 ports blasting 10 gig at the same time, it is kind of far-fetched. So this is a manageable oversubscription ratio. But if we scroll down a little bit here, we'll see the part that I was kind of warning you guys about, FCOE support. So again, we can see there are a couple models now that do support FCOE, but this is going to be the one within the scope of the CCIE Data Center Lab. So this is kind of one of the first ones that it was actually supported on. So again, that's kind of a differentiator between it and some of, even the 1 gig models that are out there now. So let's go back to the presentation. So what I want you guys to understand about FEXs is they speak a kind of special language, and that language is called VNTAG, or 802.1 QBH. So what Cisco's done is they've actually, all the front panel ports on these fabric extenders, they actually get a special little tag value. And the communication between the parent switch and the fabric extender is actually using this VNTAG technology. So imagine that we have, a parent switch up here, and then he is connected down to a FEX. Well, this FEX is going to have all of these physical front panel ports. Okay, so kind of envision all those guys. These within VNTAG lingo are actually called our HIFs. So this would be an example of a HIF, or a host interface. So the host interface is the physical port on the front of the fabric extender itself. If you see the term NIF, that is network interface, and that's basically going to be synonymous with your fabric uplinks, so the links between the fabric extender and the parent. And then the other two, which are LIF and NIF, they're kind of nifty if you think about it. Again, I came back and said, where do we do all our config? We're going to do all our config on that parent switch. So what they've had to do on this parent switch is create a logical interface. So a place where we can actually put our configuration values. So a logical interface up here might be interface Ethernet, 101/1/1. And this port right here might correlate to this front panel port right here, this HIF interface. So what we do here is our normal config. We might say, switch, mode, access, switch, access, VLAN, 10. And spanning tree, port type, edge, whatever we want to put under there. But that is our configuration for this logical interface up here on the parent. So it's basically a logical instantiation of the HIF, but on the parent switch. All right, so again, we do all our config here. Now what it does is it takes this information and it'll actually push it down to the fabric extender in the form of a virtual interface, so that the FEX does know a little bit something about the configuration that's being applied to it. Now, what happens is, as something comes in this HIF interface down here on the FEX, it's going to be assigned a certain VNTAG value. Let's keep this extremely simple and say the VNTAG that's actually assigned is 5. So what it's going to do is it's going to take that existing frame, it's going to encapsulate it within VN tag with a tag of 5 and pass it up to the parent switch over the network interface. Now when the parent gets it, it's going to say, oh, okay, this is VN tag 5. It's going to find the lift that is associated to that VN tag, and now it knows how to process that frame. Okay, this is an access port, this is in VLAN 10, this has spanning tree port type edge, so we know exactly what we need to be doing with this traffic. I didn't know what to call it there for a second. But that's how we deal with the fabric extenders and the communications from the fabric extender to the parent switch. Now what you'll also see is as we bring the fabric extenders up, they're actually going to communicate with that parent switch. So they're going to go out there, they're actually going to establish an internal loopback adjacency. Yeah, and I have it over here in the 127.15.1 subnet. This is so that if the software between the fabric extender and the parent switch is kind of out of whack, the fabric extender will actually download the software from the parent switch, install it, and then reload so that it's upgraded to or downgraded to the exact same version as that parent switch. So it's actually a pretty cool process, and you'll see, they'll go through like an online sequence. They'll be downloading the software, they'll be upgrading, reboot, and then they'll come back up usually. And sometimes if you do have to do software updates, it does take quite a bit of time to do. So go ahead and erase this again. As we move on, I kind of want you guys to envision a physical FEX environment where we have some racks within the data center environment. Typically, a couple racks might look something like this. What we'll do is we'll come in here and we'll start, provisioning some servers within all these racks. So we might come in and say, hey, you get a server, everybody gets a server, and we'll throw servers everywhere. Now, what we typically would do before the advent of the fabric extender is we might come in and place, a switch in every other rack. And again, historically, with 10 gig, the switch that we might put in here for 10 gig connectivity down to the server would be something like a 4948. But what this did to us, guys, is this gave us 2 points of management. So we had a point of management here and we had a point of management here. And this sometimes was very, very costly. So it didn't scale real well. If you had to buy another one, it cost a lot of upfront cash, and then you'd have to buy all the cabling and the optics anyway. So what Cisco did is they came up with the fabric extender, and again, what it allows us to do is really provide a low-cost solution to add a bunch of port density within our racks. So what they do is now we can come in and we can place a fabric extender in the top of every rack, and what we can do is link those back to a parent switch. So the parent in this case, I have a 7K depicted here, but this would be basically our EOR or even our MOR switch, and that stands for end of row or even middle of row. TOR, EOR, top of rack, end of row is the usual lingo that you'll hear out there, but I will tell you sometimes I stick these guys in the middle and I fold all my cables into the middle because again, it appeases my OCD-ishness to do something a little bit cleaner like that than fold everything over to one side. So again, what we'll do is we'll actually cable these fabric extenders though up to this parent switch. So let's get those cables thrown in. So now they're all homed back to that big parent switch. What this allows us to do now is rather than having cabling that would have to go from over here to over here, now, let me erase that. Now we can just take that cabling straight up from the server to his local fabric extender. So we can go straight up from the server, straight up from the server, straight up from the server. So again, it does simplify cabling because now we can stay within our own rack. Now within most data centers, what you'll probably see is people like to stick a second switch in the top of every rack so that we have actually redundant switches within each rack. And again, what this allows us to do is now we can run a cable from the top FEX to the server and then from the bottom FEX to the server. In a lot of environments, you'll see these guys, they may even port channel those together. Again, what it does is it gives us redundancy in the top of every rack, and even putting dual FEXs in the top of every rack is still significantly cheaper than procuring some of those old 10 gig switches that we actually used to use. So again, this is a really, really elegant solution. Now, what I will tell you guys is that these FEXs are not smart switches. They're really just operating as remote line cards to this parent switch. And even if you think about a Nexus 7K or actually even the Catalyst 6500, these are not even distributed forwarding cards. These guys cannot do any local switching. So if you imagine we had another server right here. And imagine this server and the server below him, imagine they talked all the time. Like, it's all they did is they talked to one another, like two girls in a bathroom, right? They just talk, talk, talk. And what happens is, that was bad, I'm sorry. What happens is, when these guys are actually cabled up to the same fabric extender and they want to communicate, imagine there's only one link between that FEX and that parent switch. So what happens is he's actually going to pass the traffic up that network interface so that he can be processed by his LIF, and then it's going to be sent back out the same interface just to reach his destination. So again, if those two hosts communicate really, really frequently, what we're actually doing is sending traffic over that link and then right back across. Now, in most cases, what happens is we're going to have more than one cable stuck up between that FEX and that parent switch. So it's not so bad, but it definitely is something that I want you guys to be aware of. Another caveat is that these FEXs, on all of their front panel HIF interfaces, these guys actually run the equivalent of BPDU guard. Meaning if you get a BPDU that comes into one of those front panel ports, it will actually air disable. So we can't hang another switch. Say we had a 3560 down here. We could not hang this 3560 off of that fabric extender. It would air disable that port unless we turn something like BPDU filter on. But again, that's not going to scale very far in a true data center network. So again, big thing, we cannot run any switches off these guys because they run BPDU guard. So moving on, I have a small depiction of how I'd like you guys to view these fabric extenders. So kind of how I do. Like I said, I kind of envision them as a chassis. And what we're doing is we're just populating this chassis. So we have, the supervisors that typically go within a chassis. Well, the SUPs in this particular chassis are going to be our parent switches, right? So these are going to be the 7K, or they might even be the 5K. And then we're going to start sliding those line cards in. Those are the guys with the port capacity, right? So we're going to start placing these guys in here. And these are our actual fabric extenders. And these are going to be the guys who take those host connections down to the servers, the routers, okay, the firewalls. So what we have to do, and what we kind of have to visualize here, is if this were a true switch, like a chassis-based switch, we would identify the ports on these guys by their module number. So this would be module 1, so his ports would start with 1/1 through whatever port he ended with. But with this FEX config, we don't really have that. So what we have to do is we have to give these guys a numerical value. So as these guys actually connect up back to their parent switch, we have to give them a number. And this number is going to be between 100 and 199. So what we do, let's imagine that this FEX fabric port is going back to this parent switch on maybe port Ethernet 115. So what we might do for a simple FEX config is come in and say interface Ethernet 115. We'd put this guy in switch mode FEX fabric. And then we tell it what FEX it is. So we'd say FEX, associate, and maybe we just say 101. All right? So this tells the parent switch, hey, whatever switch is off here is switch 101, is FEX 101. So what we're going to see is now that he is 101, all of his ports are going to start with 101/1/port number. So if his port numbers go from 1 to 32, we're going to see 101/1/1 through 32. And that's how we're going to identify our fabric extender ports. What we'll actually see within our 5K or 7K or whatever our parent switch is are ports that look like that. We'll see interface Ethernet 101/1/1. This is the equivalent of our logical interface. So we could come in and put our policy under here like switch mode access and switch access, VLAN 10. This is where our policy is actually going to be applied. So it's too easy to get set up, guys. We just go in here, we'll give each of these a number, 102, 103, 104, 105, 106, 107, and 108. What we have to make sure of is when we go into our actual parent switch or parent switches, as we'll find out when we get to VPC, that we have to identify these guys correctly. You don't want to misidentify them within your config. So whatever ports these guys are going back to on the parent switch, you want to be very specific that you go in there and call out the right fabric extender number. Now, we also have to talk a little bit about pinning. And this is probably one of the more difficult things to grasp with regards to fabric extenders, but it's a pretty important topic because depending on how we cable these guys up, we're going to see different results. So the first thing I want to talk about is something called static pinning. And imagine that we have a couple links strung up between the parent switch and the fabric extender. So here, we do have the ability to port channel these together down to the FEX, but here we're not doing that. Here we're just going to do, straight up ports going down to this FEX. So again, if this were FEX 101, we might come in and say switch, mode, FEX fabric, and FEX associate 101. Whoops. And we'd take this config and we'd apply it to this port as well as this port. Now what's going to happen is, once we do that, we're going to see a little bit of config come dynamically into our parent switch. And it's going to say something like FEX 101, and then you're going to see a pinning max links, and you're going to see a number 1. This is the default value. So what this is saying is we are going to pin everything off of this fabric extender based on one link. So what you'll see is that all of these front panel ports are actually pinned to a single uplink. Amazing, right? What they're doing here is something called fixed oversubscription. All right? So if you think about it, imagine this is a 2232 PP. So what we have here is 32 10 gig ports pinned to a single 10 gig port. So essentially an oversubscription ratio of 320 to 10 or 32 to 1. Terrible, right? And what happens is, if this link goes down, guess what? All of these front panel interfaces are also going to go down. So you get kind of in a bad way there. There is a command, if this scenario were to happen, where we could take these links and move them over to the other remaining uplink, and that's by running this FEX pinning redistribute command manually within that parent switch. So again, not terribly dynamic at all, and I guess that's why they call it static pinning. What we might want to do in this specific situation, again, let me erase some of this stuff off of here, is we might want to come in and change this 1 to a 2, since we have 2 uplinks. What this is going to do is it's going to break these front panel ports into 2 different groups. So we might have this group of 16 ports and this group of 16 ports. What we might do is pin this guy to that uplink, and we'll pin this guy to that uplink. Basically, because we called out the 2 in the pinning max links command, now we're going to use both of our available uplinks to pin these guys to. So in this case, our oversubscription ratios went down. So now, rather than having 32 to 1, we'd come in and we'd have 160 to 10 or 16 to 1 on both links, which again is not really great, but it's not horrible. It's not 32 to 1 by any means. But again, if we lose one of these guys, what happens is those front panel ports that were pinned to that guy also go down. Why they call it fixed oversubscription is because we're not going to dynamically move these guys to that remaining uplink. Because if we did that, it would take it from 16 to 1 back up to 32 to 1 oversubscription. So again, in order to maintain this guy, we don't want to do that. So we leave these guys down, and basically they're just stranded. Hopefully you have redundant FEXs, so hopefully you'd have another FEX in the top of that rack, and if you had a server that was plugged into one of these ports, hopefully he was dual homed and also plugged into another FEX that is most likely still up and available on that parent switch. So this is what we call static pinning or fixed oversubscription. So I see what I did here. I actually changed to the next slide. So let me go ahead and clear this off. The next thing I want to talk about, though, is actually dynamic pinning. And dynamic pinning is actually where we come in and say we have a couple uplinks to the parent switch. And rather than just leaving them as individual uplinks, we port channel these together using mode on. Again, these FEXs are dumb switches, so they're not going to understand LACP PDUs, for instance. So we have to force that port channel by using mode on. Now what this is going to do is it's going to take all of these front panel ports and it's going to pin them to a single logical port channel interface. Makes sense, right? So we're still going to see the same thing over here. We might see FEX 101 and pinning max lengths of 1, but in that case it doesn't matter. We could have 2 ports here, we could have 4 ports here. It still looks like a logical port from the FEX perspective. So again, now we're pinning everything to the logical port channel rather than the physical port itself. So what this solves is, now if we lose one of these uplinks, it doesn't really matter, because we're just going to repin the traffic to another remaining uplink within that logical port channel. So this is typically the way that I deploy FEXs personally within the data center environment. It works very, very well, but in this case, you are kind of be manipulating the oversubscription ratio if you were to lose one of these guys. So again, here we'd have about a 320 to 40 oversubscription ratio. And again, if we dumb that down, that's about what, 32 to 8. So if we lost one of these links in here, what it would be is 320 to 30 oversubscription ratio. So again, it does get worse because we kind of balance out, with the other links. Once that other one comes back though, guess what? It's automatically applicable for pinning again because it's within that logical port channel that we're already pinning the traffic to. Go ahead, and clear this off. So next we'll get into a demo. So meet me in the next video and we'll do a demo of a standard, single homed fabric extender.